Welcome back, Geometry iPad Initiative class from OHS. This is Mr. Lane on Section 2.4, Part B, or Part number 2. We had just got done talking about one example of a counterexample for a biconditional statement. We just did Part A here, so we want to pick up on Part B here, which is a natural number n is odd if and only if n squared is odd. So I want to take some possibilities here. So again, odd numbers would be like n equals 1, n equals 3, n equals 5, n equals 7. And I could keep going on and on and on, but we're going to try these first and see what turns out here. So I want to try n squared. So if my n was 1, then 1 squared would just equal 1. Well, that's odd, so that's true, and this is true. And either way I look at it, it would be true. So n squared on 3 would be 9, which is odd, and 3 is odd, so it works out there. So n squared on 5 would be 25, so it works both ways. N squared equals 7 squared, which is 49. Both of those are odd. So I could keep going here, and I don't think I'm going to be able to come up with a situation where I start with an odd and square it and end up with an odd, or I square an odd number, end up with an odd. So I think this one I can't find a counterexample to, so it must be true. So if I could find one specific case, that would be a counterexample which would prove the biconditional false. Alright, regular class would be doing those right now. We're going to keep moving on to good definitions. And I think at the beginning of the lesson we said a good definition should be true both forward and backwards. A good definition can be written as a biconditional. And then we have one example here. It says write a good definition for a polygon. And then we have some examples of polygons given to us. And then things that are not polygons. And then we're supposed to come up with, a definition for this. Alright, now the first thing I notice on all of these examples, the sides doesn't seem to matter how many sides it has. And I don't know if you know concave and convex, but it doesn't matter if it's concave or convex. It looks like that's not real important here. One thing that I do notice that's different about the polygons and non-polygons are some of these are just not closed. So, and by closed I mean if there was an animal trapped inside trying to get out, there's no hole for it to crawl out of. It would be enclosed in those cages that you could imagine those shapes being. So one thing I notice is that these are closed and these are not necessarily closed. Now another thing that I kind of noticed from this example, all of these have straight sides. Okay, this one here is a rounded side. So I might want to include something of that, and notice that this overlaps, so sides cannot overlap because none of these are overlapping. Okay. Other things about it, closed, non-overlapping, I think that almost pretty much does it. They're two-dimensional, not a three-dimensional. There's no three-dimensional shapes on either one. So it looks like it's just a two-dimensional object also. So let's go ahead and start writing this, and it might take a couple of times to get it just right. But we're going to put something about a polygon for its definition. Would be something along the lines of if a figure, or actually let's try and go straight to the biconditional. I was going to write a couple of conditional and then its converse. I'm going to try and go straight to the biconditional. let's see, a figure is a polygon if and only if it's a closed figure, or let's put two-dimensional figure, with straight, non-overlapping sides. Okay, and I think that would describe all of these, but then leave areas where these would not be polygons. So I think that would be something close to the definition of a polygon. That would be a good definition. Alright, let's move on. Write each definition as a biconditional. So they give us a definition, and we're supposed to write it as an if and only if statement then. Alright, so a triangle, or we probably should start say figure is a triangle if and only if it is a three-sided polygon. So I just rewrote that definition as a biconditional or an if and only if statement. And I think we got one more example here. It says a right angle measures 90 degrees. So we're going to write an angle is a right angle if and only if its measure is 90 degrees. So we just wrote it as an if and only if statement, which should be true either way that we started. We could have put an angle's measure is 90 degrees if and only if it's a right angle. So both whether we started with P or Q, it should be true on that. So let's see, regular geometry class would be doing those problems from the book at this time. We're going to keep on moving. Oh, and looks like we're done with this section. That would be the up one, down ones that we would play for the regular geometry class. iPad initiative class, we'll give away boxes at the beginning of the week, as we started doing about a week ago. So that's just for fun there. Hope you got what you wanted. And this is Mr. Lane signing off from OHS High School. Go Cyclones!